morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. Vijay Sirpati sir, seminar coordinator D.K. Sharma sir, faculty member, examiners and my batchmates. I am Tarun Kumar, pursuing my BTech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota. Today I am here to present topic of my seminar presentation on cryogenic rocket engine research development. These are the content we are going to discuss. So let's start. Firstly, introduction to cryogenic. Cryogenic is derived from Greek. Cryo means cold. Genes means production. Cryogenic is the study of production and behavior of material at very low temperature below -150 degrees Celsius. Oxygen liquefies at -183 degrees Celsius. Hydrogen liquefies at -253 degrees Celsius. Introduction of cryogenic rocket engine. A cryogenic rocket engine is an engine which uses cryogenic fuel. Cryogenic fuel are fuel that requires storage at extremely low temperature in order to maintain them in a liquid state. Various cryogenic fuel oxidizer combinations have been fired, but the combination of liquid hydrogen and liquid oxygen oxidizer is mostly used. Now coming to the history of cryogenic. The RL-10 was the first liquid hydrogen cryogenic rocket engine to be built in the United States, and development of the engine by Marshall Space Flight Center at Pratt and Whitney began in the 1950s, with the first flight occurring in 1961. These engines were one of the main factors of NASA's success in reaching the moon by the Saturn V rocket. Now coming to the construction. The thrust chamber or combustion chamber, fuel injector, fuel turbo pumps, gas turbine, cryovalves, regulators, the fuel tanks, rocket engine. Now coming to the working principle. The basic working principle driving a rocket engine are Newton's third law of motion, law of conservation of momentum. In principle, cryogenic rocket engine drives thrust like all other rocket engine by accelerating an impulse carried to high speed. The chemical energy stored in the fuel is converted into kinetic energy by burning fuel in the thrust chamber and subsequently expansion in nozzle to produce thrust. Now coming to the rocket engine power cycle. Gas pressure feed system, gas generator cycle, stage combustion cycle, pump feed system. Gas pressure feed system. The pressure feed engine is a class of rocket engine. Helium is used as a pressurized propellant tank to force the fuel and oxidizer to the combustion chamber. Tank pressure should exceed the combustion chamber pressure. It's a simple pumping and unreliable turbo pumps. If the fuel is hyperbolic, then they burn as contact. If not, igniter burner is required to ignite. Uses quad rocket, Aquarius launch vehicles. Gas generator cycle. The gas generator is a power cycle of a bipropellant rocket engine. Some of the propellant is burned in a gas generator and resulting hot gas is used to power the engine's pumps. Some of fuel is a gas generator cycle may be used to cool the nozzle and combustion chamber. Uses F1 rocket engine, Vulcain, CE20, etc. Now coming on stage combustion cycle. It is a bipropellant rocket engine. One propellant is sent through pre-burner and partially burned using a small portion of second propellant. The resulting hot gas is used to power engine turbine and pumps, then injected into main combustion along with the remainder of second propellant to complete combustion. In stage combustion, all the cycle of gases and heat go through the combustion chamber. Now coming on pump feed engine. It is a power cycle of biopropellant rocket engine. It uses dual electrical pump to increase the pressure from the tank to combustion chamber. Pump is actuated by an electrical motor fed by a battery bank. Inverter converts DC current to AC current. Advantages: high energy per unit mass. Propellants like oxygen and hydrogen in liquid form give very high amount of energy per unit mass, due to which the amount of fuel to be carried about aboard the rocket decreases. Clean fuels. Hydrogen and oxygen are extremely clean fuels. When they combine, they give out only water. This water is thrown out of the nozzle in form of very hot vapor. Thus, the rocket is nothing but a high-burning steam engine. Economical. Use of oxygen and hydrogen as fuel is very economical, as liquid oxygen costs less than gasoline. Disadvantages. Boil-off rate. Cryogenic fluids are difficult to store for longer period. Highly reactive gases. Zero gravity condition. Leakage. Highly density requires larger tank. Hydrogen embrittlement. The next generation of rocket engine. All rocket engines burn their fuel to generate thrust. If any other engine can generate enough thrust, that also can be used a rocket engine. There are lot of a plan of new engines that our NASA scientists are still working with. One of them is xenon ion engine. This engine accelerates ions of atomic particles to extremely high speed to create thrust more efficiency. NASA's Deep Space One spacecraft will be first of ion engines for propulsion. These are some alternative solutions like nuclear thermal rocket engines, solar thermal rockets, the electric rocket, etc. Conclusion. The area of cryogenics in cryogenic rocket engines is a vast one, and it cannot be described in a few words. As the words progress, new developments are being made, more and more new developments are being field of rocket engineering. Nowadays, cryopropellant rocket engines are having a great demand in the field of space exploration. Due to the highly specific impulse obtained during the ignition of fuels, they are much demand. I hope you all are clear. If you have any question, then you may ask.
Why do hybrid rocket engines are called as liquid propellant rocket engines?
Because fuel used in liquid state. So we call the hybrid rocket engines as liquid propellant rocket engines.
Okay.
These are some references. Thank you.